Earth's magnetic shield under assault. What scientists aren't telling you about the perfect storm. Our planet is being hammered by a high-velocity stream of charged particles traveling at 435,000 miles per hour, originating from an unusual gap in the sun's magnetic armor. This coincides precisely with an interstellar visitor, designated Comet 3 I-Atlas, disappearing from view as it swings behind our star. Researchers are calling this a perfect coupling scenario. Earth's magnetic defenses are compromised, and geomagnetic disturbances can cascade through our atmosphere with minimal resistance. Simultaneously, a cluster of intense seismic events has sparked heated debate in the scientific community about whether these phenomena are connected or merely coincidental timing. The mainstream narrative insists there's no relationship between these occurrences, yet this interstellar wanderer is interacting with our sun in unprecedented ways. When it emerges on the other side, what scientists discover could fundamentally alter our understanding of cosmic mechanics. Decoding the solar threat. So what does an event of this magnitude actually mean for our world? A coronal gap isn't literally a cavity in the sun's surface. It's a zone where the solar atmosphere becomes thin and magnetic field lines extend outward into the void, unbound. Across most of the sun's face, magnetic fields form closed loops that cage superheated plasma. Inside these gaps, however, those field lines split wide open like an unguarded portal, releasing charged particles at phenomenal velocities. Satellite imagery reveals these regions as dark expanses that can stretch across thousands of kilometers, sometimes bridging opposite hemispheres of the sun. When such a gap spans the solar equator, it creates a transquatorial corridor for solar wind, linking north and south poles while directing energy straight toward nearby worlds. The October 2025 phenomenon started when solar imaging systems detected an exceptionally wide unipolar gap spanning the sun's equatorial region. Magnetometer readings confirmed the field structure was negative and open, a rare configuration typically seen only during solar minimum periods. This exposed architecture permitted a high-velocity outflow measured at 700 kilometers per second to break loose and surge through inner space. Space weather specialists describe these zones as magnetic exhaust ports where solar plasma doesn't merely simmer but rushes outward without constraint. The trajectory and polarity of this discharge are crucial factors. When a sun's open magnetic structure aims directly at our world, Earth's protective magnetic envelope must withstand a concentrated, relentless bombardment. This represents the physical foundation behind what experts term the perfect coupling configuration. The magnetic gateway stands wide open. The particle stream moves at extreme speed, and Earth sits squarely in the crosshairs. When solar wind collides with Earth, solar wind doesn't simply glide past our planet. When a high-velocity stream arrives, particularly one moving at 700 kilometers per second, Earth's magnetic shield enters direct confrontation. The critical interaction occurs at the boundary where solar and terrestrial magnetic fields meet. Here, the interplanetary magnetic field serves as the decisive factor. During October 2025, this field pointed sharply southward, maintaining steady readings near -12 nanotesla. This orientation matters immensely because Earth's magnetic field points northward. Opposing directions allow the fields to merge through a process called magnetic reconnection, the gateway through which solar energy floods into Earth's magnetosphere. These dynamics translate into tangible consequences: power infrastructure fluctuations, satellite orbital decay, and most spectacularly, auroral displays extending far beyond their typical range. On October 12th, luminous curtains danced across skies as far south as the Great Lakes and New England, direct evidence of efficient coupling between solar and terrestrial systems. The outcome? A geomagnetic environment primed for chain reactions, where even moderate solar wind can trigger cascading effects throughout our planet's upper atmosphere. Each surge in velocity, every shift in magnetic polarity sends disturbances rippling through the global electromagnetic environment. The interstellar anomaly. Comet 3 I-Atlas isn't just another frozen wanderer. It's only the third confirmed interstellar object ever detected, and its chemical composition challenges fundamental assumptions about cometary science. Most solar system comets emit primarily water vapor, but this visitor is radically different. Its surrounding cloud is dominated by carbon dioxide, outgassing at rates nearly 8 times greater than water. A signature characteristic of objects formed in the frozen realms far beyond Neptune's orbit rather than anywhere in our local neighborhood. Spectroscopic analysis from ground and orbital observatories reveals a nucleus smaller than 1 kilometer across, yet active enough to shed material at rates reaching 4 kilograms per second. Even at distances of 4 to 5 astronomical units from the Sun, it was already generating a visible haze, the cloud of gas and dust that forms when solar radiation heats the nucleus. The dust particles tell another intriguing story. Rather than fine grains that create extended, glowing tails, this comet appears to produce larger, heavier fragments. The result is a faint, asymmetric shroud rather than a dramatic streamer. Its rotation period, measured at just over 16 hours, matches the tumbling motion observed in other active comets. But the surface chemistry details, rich in organic compounds with an exceptionally high carbon dioxide to water ratio, set it distinctly apart. As one mission researcher noted, this is a messenger from beyond our stellar neighborhood, carrying a chemical blueprint we've never encountered. This uniqueness transcends mere curiosity. It's a critical test case for understanding how interstellar chemistry responds to solar heating and what revelations might emerge as it completes its closest approach. The seismic coincidence controversy. A series of magnitude 7 earthquakes shook seismometers across the Pacific Ring of Fire during the exact week that this interstellar visitor vanished behind the Sun and solar wind battered Earth's magnetic defenses. The timing ignited widespread speculation, with some suggesting the solar outburst or the comet's passage triggered the seismic activity. However, when analyzed against historical baselines, the data reveals a different picture. According to space weather monitoring agencies, Earth experiences approximately 15 magnitude 7 or greater earthquakes annually. This week's activity, while striking, remains within normal statistical parameters. No established seismologist recognizes a direct physical mechanism connecting solar wind to tectonic plate movement. Comprehensive analyses of decades of records find no consistent pattern linking solar storms to earthquake timing. Yet speculation endures. Fringe hypotheses invoke ionospheric interactions or subtle rotational changes, but these remain unverified and outside mainstream geophysics. As forecasters emphasize, the burden of evidence rests with those proposing a connection. Without a reproducible mechanism or clear statistical deviation, science treats these events as temporal coincidence rather than causation. This debate extends beyond academic discourse. It establishes the threshold for what qualifies as evidence when extraordinary claims confront empirical data. For possible fates, 4 distinct scenarios await on the Sun's far side, each leaving unique signatures in observational data before the comet itself becomes visible again. Scenario 1. Intact survival. The simplest outcome. The comet reemerges with brightness following preconjunction predictions. Steady, perhaps dim, but unmistakably on track. Its surrounding haze remains compact with no sudden variations. This is what most comet researchers expect, though it's the least dramatic possibility. Scenario 2. Breakup. The narrative shifts instantly. Spacecraft coronagraphs would detect a sudden brightness surge, often exceeding 1 full magnitude. Instead of a single point, images might show a chain of fragments stretching along the orbital path. The dust cloud expands, the haze blurs, and the tail may bifurcate or distort. Historical cases showed these telltale signs: abrupt brightening, split tails, and multiple light sources where only one should exist. A sodium tail, rare, brilliant, and yellow-tinged, can flare dramatically following violent disruption. Scenario 3. Dormancy. The comet emerges, but its activity has collapsed. The haze contracts, the tail vanishes, and the nucleus appears almost point-like, faint, unresolved, potentially lost in solar glare. Brightness drops below forecasts, and ground-based instruments may struggle to recover the object entirely. Scenario 4. Complete destruction. The most dramatic outcome. The comet simply fails to reappear. No trace in coronagraph imagery, no fragments, no outburst, just an empty void where the nucleus should be. The only evidence might be a ghostly dust trail or a brief, unanticipated brightness spike as the nucleus vaporizes. Each scenario leaves distinctive fingerprints in the data. When new images arrive, these are the markers to watch for. The recovery protocol. Recovery begins with spacecraft coronagraph images uploading to archives every 12 minutes. Comet hunters worldwide scrutinize each frame for signs. A faint point, sudden brightening, or subtle background distortion. When data streams show anything unusual, alerts ripple through the observing community. Robotic telescope networks take over next, programmed to sweep the region once the comet moves beyond solar glare. These facilities cover vast sky areas in single exposures, flagging anything that shifts position or changes brightness. Automated systems compare fresh images against star catalogs nightly, identifying movement or brightness changes. If candidates appear, photometry protocols activate. Observers measure light across multiple wavelengths, logging magnitude and color in real time. Steady, predictable increases support an intact comet. Sudden jumps suggest fragmentation or outburst. Amateur astronomers provide critical redundancy. With proper timing and modest equipment, backyard observers can confirm or challenge early detections, filling gaps between professional surveys. Every sighting logged with precise coordinates and brightness builds an evidence chain tracking the comet's recovery. Your cosmic viewing opportunity. Every clear morning for the next 2 weeks, a different comet awaits in the eastern sky. Comet C/2025 A6 now glides through Cancer, rising before dawn and offering anyone with binoculars a rare chance to witness a solar system visitor in motion. No telescope necessary. Simply step outside 1 to 2 hours before sunrise, find a spot with clear eastern horizon views, and scan just above Cancer's familiar stars. The comet's predicted magnitude between 4 and 5 makes it bright enough to appear as a fuzzy, diffuse patch through binoculars, though not obvious to naked eyes. Under dark skies, the surrounding haze may show as a soft, round cloud with a subtle tail stretching away from the sun. Timing is critical. The next 14 mornings are optimal as the comet climbs higher daily while the moon stays absent. By mid-November, it will fade and slip closer to solar glare, making this window the best opportunity for first-time comet observers. Stay connected to the cosmos. If you're fascinated by these cosmic events unfolding above us, solar storms, interstellar visitors, and the mysteries waiting to be discovered, don't miss what happens next. Subscribe to stay updated as we track the return of 3I Atlas, decode the data as it arrives, and explore the next chapter of this unfolding story. Every observation brings us closer to answers, and you'll be among the first to know when the silence finally breaks. Hit that subscribe button and join a community that looks up, asks questions, and refuses to miss the show our universe puts on every single day.